Hello guys, and today is a new tutorial in our YouTube channel, Science and Engineering, and it's about basic electrical engineering, the concept of voltage divider. And as we can see here in this schematic, we have a DC circuit where we have two resistors, the R1 and the R2. R2 would be a variable resistor which will change from a values of 1 kilo ohm to 6 or 7 kilo ohms. And we are going to measure the voltage here, V2, across this resistor R2 to see what are the changes and the effect of changing this, the values of this resistor R2 while keeping this R1 constant at 1 kilo ohm. Our supply here is 10 volts here, as we can see. And the simple equation for the voltage divider is actually what we see here, is that the voltage V2 at any time would just be equal to R2 divided by the sum of the two resistors R1 plus R2, and the whole thing is multiplied by the supply voltage. And the way we derive this equation actually is, we can see it here, is the V2, which is the voltage across this resistor R2, is equal to the current passing in this circuit here multiplied by R2. So V2 is just I multiplied by R2, and the total voltage in this circuit is just this current multiplied by the sum of these two resistors here, R1 plus R2. So we get these two equations here, and if we divide V2 divided V, as we see here, then the I cancels and we get this R2 divided by R1 plus R2, and then we move the V to the other side, and when we get this final formula here for the voltage divider. Now just a small remark about this voltage divider formula is we can see that we know that the R1 will be constant and our supply voltage here is going to be constant all the time. So the only changing parameter here or variable here will be this R2. And as we can see, that it is clear that as the R2 increases, then the V2 will also increases. But here we don't forget also that in the denominator here we have also R2. So actually at the same time the R2 is increasing, the numerator is increasing, but also the denominator is also increasing. This tells us that the changes here will not be like a linear changes. So for example, if we change the R2 from 1 kilo ohm to 2 kilo ohms, we don't expect that the voltage V2 will also change in a linear way from a value, for example, 5 volts to 10 volts. It will not be doubled if we double the resistor value here, as we can see from this equation. So let's do the simulation for this, and as we can see in the results of the simulation here we have in red, that is the voltage V2 across the resistor R2, and here in green is the current in the whole circuit, since the two resistors are in series, so the current is the same in both resistors. Now as we can see that a change of the value here of the resistor from 1 kilo ohm to 1.5 kilo ohms, that's almost half kilo ohm, has changed the voltage value from 5 volts to 6 volts. So just half kilo ohm has changed the value to by 1 volt. However, if we move a little bit to right, we can see that the change from 1.5 kilo ohm to 2 kilo ohms did not give us the same effect like what we saw previously. So the increase is now from 6 to almost 6.8 volts and not 7 volts. So as we can see, as we move forward and we increase the value of the resistor R2, we don't get a linear change, and this is because of the shape of the equation that we have seen. It's a non-linear equation, and it's obvious here that if the value of R2 is 1 kilo ohm, we get 5 volts. This we can also see it from the equation here, if this one here is just 1 kilo ohm. Same like this one, if we put this in the equation here, then 1 divided by 1 plus 1 is 2, so it's half. So we just get half the value here of our supply voltage. That would be 5 volts. So we start from 5 volts and then we go upwards to a certain value which is also limited, because if this R2 actually increases even to infinity, it acts here like an open circuit. And if this thing is like an open circuit here, then we don't have a current flow and we don't have a voltage drop across this R1. So we get the whole voltage here of the supply voltage here at this point. This means that the maximum that we can reach here is actually limited by 10 volts, even if we increase this resistor to an infinity, which is like an open circuit. So if we make an open circuit here, then no current will flow, then the volt here at this point is exactly the volt here at that point. And this is one extreme. The other one, or the other end, is that if we make this R2 equals to 0, so it's clear from this equation that 0 divided by anything is 0, so we get a 0, so it will be exactly the ground volt here, which is 0. So we are actually between 0 and 10. This circuit voltage divider tells us also another thing, that this R1 is also limiting the current in the circuit. So this circuit we cannot get a short circuit because we cannot get a 0 resistor value here across this in this circuit, because in the end the total resistance is just the sum of R1 plus R2. So even if R2 is 0, which is like a short circuit, we still have the value of R1, so we will never come to a short circuit. If we go back to the simulation here, we can see the green, which is the current. It starts with the 5 milliamps, and as we increase the value of the resistor R2, the sum of the two resistors of course will increase, so we get a decrease in the current, and it's also a non-linear decrease in the current. However, it is exactly moving or following the same pattern of the voltage, so they are decreasing at the same rate or increasing at the same rate where they intersect here. And again, the limits would be also if this resistor here is just a 0 kilo ohm, the R2 is 0 kilo ohm, this one is 0, so the current passing in this circuit will be just the value of this voltage divided by this R1, so 10 divided by 1 kilo ohm, which will give us the value of 10 milliamps. So we start from 10 milliamps. However, because we have the R2 starting at 1 kilo ohm, so we get half this value, which is 5 milliamps. And then we go downwards. The more we increase the value of the resistor R2, the more we decrease the current passing in the circuit. And again, we can go to a minimum of a 0 if this resistor is like very high, almost infinity, so we get an open circuit, so we don't get any current passing here in this circuit. One last thing here about this voltage divider is we have seen that since these changes are like non-linear, so a change from a resistor here, from a resistor value of 1 kilo ohm to 1.5 kilo ohm here, has made 1 volt changes here in the circuit here, across the R2. This shows us that the first, or the few changes here, or the small changes here in the resistor, the first small changes here have great effect on the voltage. So this gives us high sensitivity at this region, where this sensitivity tends to be less and less, and the curve is getting more flat, and the sensitivity is not that big as we go forward. This can be used in some applications like the Wheatstone bridge, which we can discuss also in another tutorial. So hope you enjoyed the tutorial, and if you have any comments or questions, just put it in the video in the links in the video comments down below. Thank you. Have a good day.